Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0A94, refers to a performance problem specifically with the DC-DC converter in Honda Accord models from 2017 to 2023. The DC-DC converter is a crucial component of the vehicle's power management system, responsible for converting high-voltage direct current DC from the hybrid battery pack to low-voltage DC, which is required for various electrical components. The DC-DC converter is typically located near the vehicle's battery within the power control unit. This issue may lead to inefficiency in running accessories, charging the battery, or even stalling the operation of key components. Identifying this DTC promptly is critical, as it can affect the vehicle's performance and safety. Malfunctions in the DC-DC converter could potentially lead to further electrical issues if not addressed swiftly. The DTC P0A94 indicates a problem with the performance of the DC-DC converter, which is vital for converting high-voltage DC from the hybrid battery to the required low-voltage DC for vehicle systems. This converter is primarily located close to the hybrid battery, facilitating efficient power management for various electrical systems in the Honda Accord. Essential components affected by this issue may include the vehicle's ECU, lights, and other critical electronics that ensure proper vehicle functionality. When diagnosing this DTC, the Honda Diagnostic System, HDS, scanner becomes essential as it provides the necessary data to assess the converter's performance and detect any issues. The system checks for DTCs and assesses communication between components, crucial for the vehicle to perform correctly. Several possible causes may lead to DTC P0A94. Wiring issues, including short circuits within the wiring harness, can disrupt the signals required for the DC-DC converter to function effectively. Blown fuses, often caused by excessive current flow, may impact the converter's ability to operate. Furthermore, the DC-DC converter itself could be malfunctioning due to internal faults, which would directly generate the code. Connection problems, such as loose or corroded terminals, can also cause interruptions in communication between the DC-DC converter and the powertrain control module, PCM. Each of these possibilities should be methodically examined to identify the precise cause of the DTC appearance. Symptoms of the P0A94 DTC could manifest in various ways, impacting the overall performance of the vehicle. One common indicator is the amber light blinking on the dashboard, which alerts the driver to potential hybrid system issues. Additionally, the engine may stall unexpectedly, especially under conditions where the auto idle stop feature is activated. Drivers might also notice poor performance of electrical components, like dimming lights or malfunctioning accessories due to insufficient power. Voltage abnormalities, visible through diagnostic tools, may further confirm issues related to the DC-DC converter. Collectively, these symptoms emphasize the importance of prompt troubleshooting to prevent more severe failures. The first step in troubleshooting DTC P0A94 involves putting the vehicle into the on mode. This step allows the Honda Diagnostic System, HDS, to communicate with the vehicle's various control systems. After ensuring the vehicle is in this mode, the next action is to clear any existing diagnostic trouble codes. Clearing the DTC helps reset the system and provide an accurate picture of current status. Following this, turn the vehicle to the off or lock mode and proceed to test drive the vehicle while observing the auto idle stop system in action. The aim here is to confirm whether the amber indicator light blinks or if the engine continues to run when it should stop. If persistent issues arise, checking for new confirmed or pending DTCs with the HDS will reveal more about the underlying problems. In Step 2 of troubleshooting DTC P0A94, the technician should check for any new diagnostic trouble codes using the HDS. If the P0A94 code is still indicated, this confirms that the problem persists. Subsequently, inspect the auxiliary under-dash fuse or relay box for any blown fuses. Should any fuses be found blown, it is essential to address the underlying short circuit that may have caused the failure. If fuses are intact, check for poor connections or loose terminals at both the DC-DC converter and the powertrain control module, PCM. The stability and security of these connections are critical for proper communication and operational efficacy. This systematic examination assists in narrowing down the potential failures affecting the DC-DC converter. Step 3 of troubleshooting involves evaluating parameters related to the DC-DC converter using the HDS. This entails checking specific signals and current conditions to confirm their alignment with the expected threshold values. This assessment is crucial in determining if the current conditions fall within acceptable limits. If the conditions match the thresholds, the technician can proceed to the subsequent steps in the troubleshooting process. On the other hand, if discrepancies are noted, immediate action is required to identify the source of the fault. This could represent issues directly related to the DC-DC converter, which deeper troubleshooting steps will aim to clarify. In Step 4, the technician will examine for any shorted wires, particularly focusing on the DC-DC STS line. First, ensure the vehicle is turned off or in the lock mode. The procedure involves using HDS to jump the SCS line, followed by a wait period of over 1 minute to allow sufficient time for assessment. Subsequently, disconnect the required connectors from the DC-DC converter and the PCM. Continuity testing is essential, focusing on the DC-DC converter connector A and body ground. The goal is to confirm continuity, ensuring resistance measurements are at or above 1 megaohm. If the measurements confirm that the DC-DC STS wire is functional, the next step would be to replace the DC-DC converter. However, if the tests reveal issues, immediate repair of the identified short is necessary. Step 5 involves conducting an open wire check, focusing on the GND line, which is critical for the proper operation of the DC-DC converter. First, switch the vehicle to the off or lock mode and disconnect the DC-DC converter connector B. Next, continuity between specified test points should be measured, specifically between the DC-DC converter connector B, female terminal number 4, and body ground. The aim is to ensure that there is resistance of 1.0 ohm or less. A confirmed value at this level signifies that the wiring is intact. If the readings exceed this threshold, it indicates an open circuit that requires immediate repair to restore functionality between the converter and ground connection. Step 6 directs attention to the assessment of the DC-DC converter's input and output lines. After reconnecting the DC-DC converter connector B, shift the vehicle back to on mode. At this stage, using the HDS, specific parameters related to the converter's operation are evaluated, including potential input-output errors. If parameters indicate a malfunction, for instance, if any of the DC-DC converter input errors signify issues, then the technician must proceed to additional troubleshooting paths. These could involve checking the respective circuits for shorts or removing aftermarket components that might interfere with normal functionality. If all parameters show normal operation, this often concludes that the DC-DC converter itself requires replacement to resolve the initial performance problem indicated by DTC P0A94. Step 7 calls for another fuse check, focusing specifically on fuse number A31. Begin by ensuring the vehicle is in the off mode, allowing for safe access. Inspecting the fuse allows identification of any visible damage or breaks. If the fuse is blown, it is imperative to trace the source of the problem. Typically, a short in the +B DC-DC1 wire, located between the fuse and the DC-DC converter. If any issues are found, these must be repaired to restore the circuit's functionality, after which the blown fuse can be replaced. Conversely, if the fuse is intact, it indicates that the DC-DC converter's performance will need further examination, leading the technician to the next steps in the troubleshooting process. Step 8 focuses on checking the +B DC-DC1 line for open circuits. Begin by disconnecting the DC-DC converter connector B to isolate the circuit. With the vehicle off, measure the voltage between specific test points to confirm the presence of battery voltage. Ensuring that this voltage is at appropriate levels indicates that the +B DC-DC1 wire is intact and functioning as intended. If it meets expectations, it corroborates the need to focus on replacing the DC-DC converter itself to resolve the P0A94 DTC. If the voltage is absent, a repair of any open circuits between the DC-DC converter and the associated fuse must be executed to restore normal operations. In Step 9, the focus turns to inspecting fuse number A41 for functionality. After ensuring that the vehicle is in off mode, check the fuse for any damage or discoloration that might indicate it has blown. If the fuse is found to be faulty, the source of the fault must be meticulously tracked, typically focusing on the +B DC-DC2 wire. Repairing any identified short circuits and replacing the fuse will be necessary to maintain system integrity. Conversely, if the fuse is intact, the technician should consider further investigation of the DC-DC converter itself or associated components, continuing the diagnostic pathway to resolve the P0A94 issue effectively. Step 10 entails another open wire check, focusing this time on the +B DC-DC2 line. Disconnect the DC-DC converter connector B and measure the voltage at the specified terminals to confirm the presence of battery voltage. Ensuring that there is voltage indicates that the +B DC-DC2 wire is appropriately functioning, which would eliminate the possibility of wire issues from the problem. If the voltage readings verify the system is operational, replacing the DC-DC converter becomes the next step in resolving DTC P0A94. If voltage is not present, the technician must address any functionality issues related to the wiring connecting the DC-DC converter and the associated fuse. Upon completing the necessary repairs dictated by earlier troubleshooting steps, a final verification of repairs against DTC P0A94 is essential. Begin by testing the vehicle to ensure all systems are operational. Utilizing the HDS, clear any remaining diagnostic trouble codes and take the vehicle for a test drive, monitoring crucial systems during operation. Pay close attention to any warning lights or performance anomalies that might signify unresolved issues. If the amber indicator light remains off and the vehicle performs as expected, it confirms successful resolution of the original performance problem. Comprehensive testing ensures that the repair was effective and that the DC-DC converter now functions correctly within the vehicle's electrical system. Preventive maintenance is crucial in avoiding the reoccurrence of DTC P0A94 and other related issues. Regular system checks and inspections of key components, including the DC-DC converter, can help identify potential failures before they escalate into significant problems. Inspecting wiring connections for wear or corrosion regularly ensures that the systems remain functional and that communication is uninterrupted. Monitoring for any warning lights or changes in vehicle performance may offer early indicators of underlying issues, prompting proactive measures. Ensuring that fuses are kept in good condition and that any that blow are replaced promptly can preserve the integrity of the electrical system. By adopting a proactive maintenance schedule, vehicle owners can improve the durability and reliability of their Honda Accord. In summary, understanding and addressing DTC P0A94, which indicates a performance problem with the DC-DC converter, is vital for any Honda Accord owner. Recognizing the symptoms and utilizing a systematic approach to troubleshooting helps simplify the diagnostic process. By following the specified steps, technicians can efficiently identify and replace faulty components that hinder the DC-DC converter's functionality. Conducting a final repair verification ensures that the problem has been adequately resolved, maintaining vehicle performance. Furthermore, implementing a rigorous preventive maintenance schedule helps ensure long-term reliability, allowing the vehicle to operate as intended. Please like and subscribe to the channel. See you next time.